Welcome to mathematics class, and now we are going to talk about constructions. So let us see what are the topics to be covered. Under the heading construction, we will first have an introduction to construction, then we will learn about basic constructions, then we will look at some constructions of triangles. Given either the sides or the angles, we will see how to construct different types of triangles. Now let's have a quick introduction. First of all, why do we need construction? And the simplest answer to this question is to draw accurate figures at one go, right? If we want to draw exact figures, whatever the data is given, if we want to draw the exact figures according to whatever data is given, then we can use the methods used in construction to draw that geometrical figure very easily and accurately at a single go, right? By trying only once, we can draw the exact figure we need. And in this chapter, we will see the construction of angle bisectors, perpendicular bisector, and different types of triangles, right? We will look at angle bisectors, perpendicular bisector, and different types of triangles. So let us start with the basic constructions. Here, for the first time, we are looking at construction of the angle bisector. We are looking at the construction of the angle bisector. Now if we are given such an angle as it is given here, what we do, we take this point as the vertex, and by taking a certain gap within the arms of the compass, we draw an arc. We draw an arc like this. Taking this point as the center, we draw an arc like this. As you can see here, we have drawn an arc. Now what we do, these 2 points are our new vertices, right? This was our initial vertex from where we had drawn an arc. These 2 points are our new vertices. So let us take them one by one. Let us take this vertex first and draw an arc here. We are keeping the metal pin of the compass here and drawing an arc here, right? You have seen, taking the vertex A as it is written here, taking the vertex A, we have drawn an arc, right? We have drawn an arc by taking the vertex A. Do the same thing with the second vertex. Call it B. Call it B and do the same thing by taking the same radius as you had done with A. Whatever radius you had taken for A, you should take the same radius for B also, right? You can see this radius as well as this radius are same, right? So what we did, by taking A as the vertex, we had drawn an arc with a particular radius. By taking point B with the same radius, we have drawn one more arc that cuts the earlier arc, right? It cuts this arc at this point. It is drawn here, right? Both the arcs cut each other at this point, the darkened point. So by joining this vertex with this vertex by this point, right, that we have got now, by joining these 2 points, we get an angle bisector, right? You can see this angle looks almost equal to this angle, right? Here I am calling it almost equal because I cannot measure it exactly, right? I cannot measure it exactly here on the screen, but if you take this on a sheet and measured with a protractor, you will find that the two angles are exactly equal, right? So let me repeat the steps. First, take this vertex and draw this arc, right? Then these 2 points where it cuts the arms becomes our new vertex. Take a particular radius and with vertex A draw an arc. This arc, we have drawn an arc, this one for A. Do the same thing and with the same radius for B, and this we have drawn for B, right? And wherever they cut, join that point with the vertex of the angle, and thus we get the angle bisector of the given angle, right? So you can see it is very easy to find out the angle bisector of any given angle, and that too very accurately. So let us construct a perpendicular bisector now. Now for being a perpendicular bisector, the line first has to bisect the given line segment, and secondly the line also has to be perpendicular to the given line segment, right? So what we are going to construct should be a bisector of AB as well as perpendicular to AB, right? So let us see how to do that. First, take A as the vertex and take a radius more than half of AB, right? This is half of AB. Suppose take a radius somewhere here, right? Take this as the radius. This is the half of AB. Take the radius a bit more than half of AB, and you will understand why. Okay, so you have taken more than half of AB, the radius. Draw an arc by taking A as the center. By taking A as the vertex, draw an arc, and with the same radius draw an arc taking B as the vertex. So this is the arc with A as the vertex, this is the arc with B as the vertex, right? And you can see they cut each other at 2 points, right? This is 1 point and this is 1 point, right? Now if we join the 2 points, we will get a line that is a bisector of AB as well as perpendicular to AB. This line, the orange line here, is perpendicular to AB as well as divides AB into equal halves, right? So how did we do this? You can see if these are if this is a straight line, and if we take the two endpoints as the center and draw circles with radius bigger than half of their length, they will intersect at a point above and below the given line segment, right? So if we join those 2 points, the points will obviously give us a straight line, right? This is the concept used here. So what have we done here? First we have taken A and drawn an arc with radius more than half of AB. We have taken B as the vertex, and again with the same radius we have drawn another arc, and then we have joined their intersecting points to get the perpendicular bisector of a line segment. So you have seen how we can bisect an angle and also how we can perpendicularly bisect a given line segment. Okay, I think this construction you know, but still let us do it once more. Construct an angle of 60 degree at the initial point of a given ray. So a given ray is AB, whose fixed point or the initial point is A, right? So we have to draw an angle like this. This is a rough sketch. We have to draw an angle like this, and this angle should measure 60 degree. And it is always helpful to have a rough idea in mind before actually stepping into the actual construction. So here we have the rough idea of what we are going to draw, right? So we are going to apply our basic construction rules to obtain this angle. So what we do, we are given this ray. So we take A as the vertex, and draw an arc. We take A as the vertex and draw an arc which cuts AB at a certain point, say D. It cuts AB at D, right? Now don't change the radius of your compass. With the same radius as you have drawn this arc, with the same radius, take D as the vertex now. Take D as the vertex now and draw an arc such that it cuts the initially drawn arc, right? So first we have taken A as the vertex and drawn an arc, this arc which cuts AB at D, and then we have taken D as the vertex and with the same radius we have drawn one more arc which cuts this arc at a certain point, right? The new arc with D as the vertex and the same radius cuts the initial arc at certain point. So if we join this point and this point, what should we get? We should get the required angle. We should get an angle measuring 60 degrees, right? And why is this happening? You can see we have taken the same radius for this arc, right? For the arc with vertex A. For this arc we have taken a certain radius, right? So this arm should be equal to this arm, right? From A to this vertex should be equal to A to D, right? And also we have taken the same length, taking D as the vertex, right? So this length, this length, the length which I have drawn now from D to the vertex we obtained, this length should be equal to all these lengths because we have taken the same radius, right? We have taken the same radius, therefore the length from D to the new vertex should also be the same to the radius we had taken earlier, right? From A to the new vertex and from A to D. So you can see we have got an equilateral triangle, right? And what is one of the angles of equilateral triangle? It is 60 degree, right? So this angle should come out to be 60 degree, and therefore this is the way we construct a 60 degree angle by the help of an equilateral triangle, which we are not showing here, but actually we are using the same concept here. So what we have drawn, from A we have drawn an arc, and with the same radius from D we have drawn one more arc which cuts the earlier arc, and we have joined that point with A to get the 60 degree angle. Okay, let's come to the constructions of different triangles, right? So here we are looking at to construct a triangle given its base, a base angle, and the sum of other two sides, right? And let us look at this kind of constructions with the help of an example. Construct a triangle with base BC equals 7, angle B equals 75 degree, and the sum of two sides AB plus AC is given as 13 centimeter, right? So we are given the base BC, we are given sum of other two sides and a base angle. So what we do first? First we draw the base as we know it, right? We know the measure of the base, so we draw the base first. We draw BC. Now we draw the base angle, right? We draw the base angle now, angle B, which is given as 75 degree. I think you know how to draw the 75 degree angle, but still we will look at it once again. And 75 degree, where does it lie? 75 degree is nothing but the angle bisector of 60-degree angle and 90-degree angle. The angle made by 60 degrees and 90 degrees, the angle which goes in between them is my 75-degree angle, right? So let us construct that. So we are constructing 60 degree first. We have drawn an arc with B as the center, and with the same radius we have drawn an arc which cuts here, as you can see. That is my 60-degree angle. And from here, taking this point as the new vertex, we have drawn one more arc here, right? We have drawn one more arc here with the same radius, and this is our 120-degree line, right? If this is 60-degree line, by taking this point as our new vertex and with the same radius, we will get another 60 degree here, right? So this, the total angle will be our 120 degrees. So 60 degree, 120 degree, and 90 degree lies in between them. So we draw an angle bisector. So taking one point as the vertex initially, so what we do, we take this point as the vertex and draw this arc, and with the same radius from this point we draw this arc with the same radius, right? And what we do, we join B with the newly obtained point. So you can see we have constructed a 90-degree angle, right? We have constructed a 90-degree angle. Now 75 degree lies in between this angle and this angle. 75 degree lies almost 75 degree almost lies like this, right? So let us try to construct that. We are drawing an angle bisector now. Taking this point as the vertex, draw an arc with a certain radius. Again, taking this point as the vertex, draw one more arc which cuts this arc, right? From this point we have drawn one arc, and from this point also we have drawn one more arc. So you can see the intersection point here. Join this point with B and we get the 75-degree angle. This is how we construct a 75-degree angle. Now just remember, while solving questions, whatever be the angles given, you should construct them by using compass only, right? You should not use any other geometrical instruments to construct these angles, because these topics come under the topics of construction, right? All these things come under the topics of construction, and your examiner evaluates you on the process you have followed, right? So always construct everything with the help of compass and scale only. So we have drawn a 75-degree angle, right, by using compass only. Now what we do, the sum of two sides is given as 13 centimeter. So from B, draw an arc such that it cuts the 75-degree line at D. From B, taking B as the center, we have drawn an arc cutting the line BD at D, right? You can see this line BD has been cut at D by the arc we have drawn taking B as the center. And what is the length of BD? Length of BD is nothing but 13 centimeter, which is AB plus AC, the sum of other two sides. Now next step is easy, join DC. So we have joined DC. Now what we do, we try to construct an angle equal to angle D at angle C with base CD. Okay, we try to draw an equal angle like D, taking vertex C and base CD. So to draw an equal angle, first draw arc from D and C taking equal radius, right? Draw an arc of equal radius taking D as the vertex and C as the vertex as shown here, right? Now taking this point as our new center, take the length of your compass, take the radius of your compass measured equal as this length, right? Take the length of your compass or take the measurement from your compass equal to this length. Draw an arc to cut this point. Taking this point as the vertex, draw an arc to cut this point. And do the same thing here as well, taking this as the vertex now. Cut an arc of the same length as you have done here, right? So if this was the arc, this is the arc here with the same radius, and you cut this angle at the point where the angle completes, right? Here the measure of the angle is only this measure, right? The angle is only up to this, so you have drawn arc up to that only. So here you have drawn one more arc of the same length. So if you draw an angle like this, it will be similar to the earlier angle, right? Because whatever you have done to D, you have done the same thing with C. So draw the angle. So you have drawn this angle equal to this angle, right? Okay, so next what we do, we join C with BD, and you can see it cuts at A, right? We join C with BD and it cuts at A, and I think you can see here we have actually got our triangle ABC, right? We have actually got our triangle ABC. Now let us see why this is happening. You can see ADC, for ADC these two angles are equal, right? Now if the two angles are equal, these two sides must be equal as well, because it is an isosceles triangle. Two angles are equal, that means the triangle which is given here is an isosceles triangle, so the opposite sides to these angles must be equal to each other. This is the base. This is the base, right? So if this is an isosceles triangle, this length must be equal to this length, right? Now if these two lengths are equal, AB plus AC must be equal to AB plus AD, right? And what was AB plus AD? It was nothing but 13 centimeter, right? If AB plus AD is 13 centimeter, so AB plus AC will also be 13 centimeter, because this is an isosceles triangle. So this is the concept we use behind construction of such kind of triangle, where we are given the base and one base angle and the sum of the other two sides. Now what have we drawn? First we have constructed the base, then we constructed the base angle, then from the arm of the base angle we have measured the sum of the other two sides, which is BD, right? We have joined D to the third vertex DC, right? We have obtained DC. Now try to construct a same angle, equal angle as that of D by taking vertex C. Draw an equal angle of D at C. So we get this angle and this angle as equal, right? And this angle cuts the line segment BD at A, right? And this point, by joining these points A, B and C, we get our final triangle ABC, right? So this is the procedure which we use for drawing such kind of triangles. Now let us see one more type of question that can be given. Now we have to construct a triangle when its base is given, a base angle is given, but now we have the difference of the other two sides and not the sum. We have the difference of the other two sides. How to do this? So let us again see this through an example. Construct a triangle ABC with base BC equals 8 cm, angle B equals 45 degree, and AC minus AB, or the difference of the other two sides, is given as 3.5 centimeters. So let us try to draw that. First we draw the base BC as usual. BC is 8 centimeter. Taking B as the vertex, now we construct angle 45 degree. You can see the steps are quite similar here because we are given a base and a base angle. So to construct them, the steps should be same as the earlier process. The only difference will come when we are drawing the other two sides, as here the difference is given and earlier the sum was given. So now what we do, we construct 45 degree, and you know 45 degree is the bisector of 90 degree angle. So let us first construct 90 degree angle. We first make the 60 degree angle. As you can see, we have cut an arc of equal length as this arc, right? So we have drawn the 60 degree angle, and similarly we have drawn the 120 degree angle by taking an arc here, by drawing an arc here with the same length. Then we draw an angle bisector of these two angles at this point, and this point gives us the 90 degree angle, right? And now we construct an angle bisector of this whole angle, right? Taking this point as the vertex, we draw one arc. Again, taking this point as the vertex, we draw one more arc. You can see by taking this point, we have drawn an arc of certain length, and taking the same length and this one now as the vertex, we draw one more arc. Taking this point as the vertex, we have drawn one more arc which cuts the initial arc at some point. Now we join B with that obtained point to get our 45 degree angle. So till now the steps were same, and now the different steps begin. What we do, we extend this line backwards. We extend this line backward to a measure which is equal to the difference of the two sides. BD, or the backward extension of our angle BD, measures the difference of two sides. BD equals AC minus AB, or BD equals 3.5 centimeters, right? So next step is again the same. Join C and D, right? Now we draw a perpendicular bisector of CD. We draw a perpendicular bisector which is shown here in yellow. We draw a perpendicular bisector of CD. You can see it cuts our initial angle at certain point. Join that point with C. Join that point with C and call that point A. Wherever the perpendicular bisector cuts our initial angle, name that point A and join that point with C. So we get AC and AB directly. So you can see ABC is our required triangle, right? Where angle B is 45 degree, BC is of 8 centimeter, and AC minus AB is 3.5 centimeters. Now what is the reason behind using this concept? I think you can observe that if this is my perpendicular bisector of this line segment, if this is yellow color line is my perpendicular bisector of line segment CD, this line segment and this line segment must also be equal. Why? Because A is equidistant from C and D, right? So AD must be equal to AC, and this forms an isosceles triangle once again, right? So this forms an isosceles triangle once again. So you can see if this one is AC, then this one is AC minus AB, right? So we have subtracted AB from it. So if we can construct this length on this side, we actually get the triangle required. This length is nothing but AB, this length is nothing but AC minus AB, right? This length is AC minus AB. So you can see we have used the concept of isosceles triangle once again to obtain the required triangle of equal sides as constructed. We have obtained equal sides as AD, on this side as AC, right? So let us repeat the steps once more. First we construct the base, then we construct our base angle, then we extend the base angle backwards to a certain point such that the measured line segment is our difference of two sides, BD is the difference of two sides, join C and D, right? We join C and D, then we draw a perpendicular bisector of CD. We draw a perpendicular bisector of CD, and wherever this bisector cuts our initial angle, that point is our vertex A. You can see the perpendicular bisector cuts our initial angle at this point, so this point was our vertex A. You can join AB and AC, and now we get our required triangle ABC, right? Okay, so let us look at one more type. To construct a triangle when its perimeter is given and two base angle is given, right? You can see here we have not got the measure of any side, unlike all the earlier cases we have talked about. In all the earlier cases we were at least given the measure of one side, and here we are not given the measure of any single side. We are given the sum of all the sides, right? So you can see we are given two base angles, angle B, angle C, and we are given the sum of the all the three sides, AB plus BC plus CA. So let us see how to construct a triangle with base angle B equals 30 degree, angle C equals 90 degree, and the sum of all the sides or the perimeter as 11 centimeter. So as we know the length of only the perimeter, let us draw a straight line whose length is the perimeter itself, right? We have drawn XY whose length is the perimeter. Now on X we construct angle B, and on Y we construct angle C. On X we construct angle B, on Y we construct angle C, and you can use the construction methods we have used earlier. For 30 degree angle you can use the angle bisector of 60 degree, and for drawing the 90 degree angle we have shown you the process twice. And now what we do, we draw the angle bisectors of our two given angles. We draw the angle bisector of angle X and that of angle Y. You can see the orange line shows the angle bisector of X, the yellow line shows the angle bisector of Y. Now these two lines intersect at certain point, right? Name that point as A. Now what we do? We draw perpendicular bisectors of AX and AY. So you can see we have drawn the perpendicular bisector of AX, this one, which cuts XY at B, and once again we have drawn a perpendicular bisector of AY which cuts XY at C. These two lines, the newly drawn lines, are the perpendicular bisectors of our initial angle bisectors. So now join AB and AC, and therefore we get our required triangle. So we get our required triangle, and now let us talk about the reasons behind it. And once again, whenever you draw a perpendicular bisector to a certain line segment and join that point with a point on the line segment, you get an isosceles triangle. The triangle ABX is an isosceles triangle. This side is equal to this side, and also for this triangle similarly this side is equal to this side, right? And this was the angle bisector, right? This was half of angle C, this was half of angle B, sorry, this was half of angle B. So as it is an isosceles triangle, this also will be half of angle B. And what is this angle? This is nothing but the exterior angle of triangle ABX, which is the sum of the opposite two angles, or the sum of the base angles, which are nothing but half of angle B. And if we add half of angle B twice, we will get angle B itself. So our exterior angle therefore becomes angle B, and similarly our angle C comes out in a similar manner, taking triangle ACY, right? So you have seen we have got angle B as 30 degrees, angle C as 90 degrees, right? And our point A is obtained by the intersection of the two angle bisectors. So let us repeat the steps once more. First we draw the base as the perimeter XY, then we construct angle B taking X as the vertex and angle C taking Y as the vertex, right? Then we draw their angle bisectors, and wherever the angle bisectors meet, we call that point as A, right? And then what we do, we draw the perpendicular bisectors of AX and AY. The perpendicular bisector of AX meets XY at B, perpendicular bisector of AY meets XY at C, right? So we have got points A, B and C. You can join them to obtain the required triangle, which is triangle ABC, right? So you have seen it is very easy to construct triangles, angles, angle bisector and the perpendicular bisectors of different line segments. So in this class we had an introduction of why do we need constructions to actually draw accurate figures at a single go, right? And then we talked about some basic constructions of different angle bisectors, line bisectors and different kinds of triangles.